Have you ever wondered what would happen to your body if you suddenly woke up on another planet, not in a spaceship, not in a simulation, but physically standing there? Would you float like a superhero? Would you struggle to stand? Or would your own weight become your greatest enemy? Now, imagine this right now. Gravity is quietly pulling you down with a force you've never questioned. But what if tomorrow that force doubled or dropped to almost nothing? Would you survive? Would your bones crack? Would your heart cope? Or would you discover that your body was never truly yours, but Earth's? Before we travel across the solar system, do one thing. Hit the like button and subscribe to Space Facts, because today we're not just talking about planets, we're testing your body against the universe itself. Gravity is something we feel every second, but rarely think about. It's the invisible force that keeps your feet on the ground, the oceans in their basins, and the moon in orbit. In 1687, Sir Isaac Newton described gravity as a force of attraction between masses. Later, Albert Einstein reshaped our understanding, explaining that gravity isn't just a pull, it's the bending of space and time itself. But here's the part most people don't realize. Gravity is not the same everywhere. It changes from planet to planet, and when gravity changes, everything changes. Let's start with home, Earth. On Earth, gravity pulls at 9.8 meters per second squared. That number defines your strength, your posture, your balance, even how your heart pumps blood upward to your brain. You were born into this gravitational environment. Your muscles developed for it. Your bones hardened because of it. Earth doesn't just hold you down, it built you. But what if we take you somewhere else? Let's begin with the moon. The moon's gravity is only 16% of Earth's. If you weigh 70 kilograms on Earth, you'd feel like you weigh just over 11 kilograms there. Imagine jumping once and soaring 6 times higher than you ever could here. Every step would feel like slow motion. This is exactly why astronauts from NASA appeared to bounce across the lunar surface. But here's the deeper question. How long could your body survive in that environment? Without enough gravitational stress, bones begin to weaken, muscles shrink, balance shifts. What feels fun at first becomes biologically dangerous over time. Now let's move to Mars. Mars has about 38% of Earth's gravity. You wouldn't float like on the moon, but you'd definitely feel lighter. Running would feel effortless, lifting heavy objects would be easier. But here's the challenge. Over months and years, reduced gravity would slowly change the human body. Future colonists would need strict exercise routines just to prevent muscle loss. Scientists studying long-term space missions already see this effect aboard the International Space Station. In microgravity, astronauts lose bone density because their skeleton no longer carries normal weight. Gravity, it turns out, is like a gym trainer you never see. Now let's push further outward to the giants. Jupiter, the largest planet in our solar system, has gravity more than twice that of Earth's. If you could stand on a solid surface there, which you can't because it's a gas giant, your 70-kilogram body would feel like 165 kilograms. Walking would be exhausting. Jumping would be nearly impossible. Your heart would work harder just to circulate blood. Simple movement demands serious strength. When gravity increases, your body fights back, but only up to a limit. And then comes Neptune. Though smaller than Jupiter, its gravity is still stronger than Earth's. The deeper you go into massive planets, the more intense gravity becomes. But why? Because gravity depends on 2 key factors, mass and radius. The more mass packed into a smaller space, the stronger the gravitational pull at the surface. Density matters, composition matters. Size alone doesn't tell the whole story. Now here's where things become extreme. What if we go beyond planets? What if we stand on a neutron star? A neutron star is the collapsed core of a massive star that exploded in a supernova. Its mass can exceed that of the sun, but compressed into a sphere only about 20 kilometers wide. The gravity there is unimaginable. A teaspoon of neutron star material would weigh billions of tons on Earth. If you somehow stood on its surface, gravity would crush you instantly. Your body wouldn't just fall, it would flatten at the atomic level. And beyond neutron stars lie black holes. When gravity becomes so strong that not even light can escape, a black hole forms. At its boundary, called the event horizon, escape becomes impossible. This is where gravity dominates completely. Time slows, space bends infinitely. Physics, as we understand it, begins to break down. So who controls gravity? No one. It is one of the four fundamental forces of the universe. It shaped galaxies, it formed stars, it gathered dust into planets, it allowed life to emerge. Without gravity, atoms would not clump together. There would be no Earth, no oceans, no atmosphere, and no us. Where is gravity strongest? Around the densest objects in the cosmos, neutron stars and black holes. Where is it weakest? In deep interstellar space, far from massive bodies. When does gravity become dangerous? When your body is no longer adapted to it, either too weak, causing degeneration, or too strong, causing collapse. And how does gravity shape your daily life? It determines how high you can jump, how fast objects fall, how blood circulates in your veins, even how tall trees can grow. Gravity defines architecture, sports, engineering, and biology. Change gravity, and civilization itself would change. Imagine sports on Mars, basketball players soaring across the court in slow motion. Imagine construction on the moon, massive structures built with minimal effort. Imagine living on a super Earth where gravity is 50% stronger, humans shorter, stockier, built for endurance rather than speed. Gravity is not just a force, it is a sculptor. It sculpts planets, it sculpts stars, and it sculpts you. Right now, as you sit watching this, gravity is pressing you into your chair. It's keeping your coffee in its cup. It's holding the atmosphere around the planet like a protective blanket. You don't notice it because it has never changed, but if it did, if it shifted even slightly, life would transform instantly. The next time you jump, remember you are not simply lifting your body. You are resisting the pull of an entire planet beneath your feet. The entire mass of Earth is holding you down, and yet you rise for a brief second before gravity gently brings you back home. That is power. That is cosmic balance. If this journey across different planets expands your mind, make sure you like this video, share it with someone who loves space, and turn on notifications so you never miss an exploration of the universe. Subscribe to Space Facts, where the universe becomes understandable, one mystery at a time.